Welcome to Ogenius Panda Virtual Labs, where students and teachers access the virtual laboratory simulations for various science subjects.
Hello, dear students. Welcome back. In this lesson, we will analyze the periodic table. We will learn the periodic table. It's an introduction to the periodic table of chemical elements. This topic is found in Senior 4, according to Rwanda Education Board curriculum, and it is under Unit 5, periodic table of chemical elements. And the part we have today, it is an introduction, a general overview of the periodic table. You will recall what we have seen in Senior 1, because even in Senior 1, we studied the periodic table, a simple introduction to the periodic table. And if you have not watched the video about the simple introduction, which is for Senior 1 students, it's better to go back and you watch the video for you to get a better understanding of what we will discuss in this video today. Here we have the objectives of our lesson. At the end of this lesson, you should be able to explain the modern periodic law and describe the different parts of the periodic table. Let's start. The modern periodic law. What does it say? Remember, we consider Mendeleev Dmitry Ivanovich as the father of the periodic table. He realized that if elements are classified according to increasing mass numbers, there was a certain periodicity in their properties. But there were some minor fluctuations which were corrected by Henry Moseley, who suggested that elements should be classified according to the increasing order of atomic numbers. So originally, elements were classified according to increasing mass numbers. But today, we use the classification which is based on increasing atomic numbers. And that was a suggestion of Henry Moseley. And that is the basis of the modern periodic law. So according to the original law, elements were classified according to increasing mass numbers. But the modern periodic law says that elements should be classified according to increasing atomic numbers. Here we have a sample of a modern periodic table. We have different parts, we have the elements, and it is very important to note that the periodic table we have today, it is not the one that was in use many years ago. So the periodic table has undergone so many modifications. And the current form of the periodic table we use today is attributed to Glenn Seaborg, who developed the format in 1945. Now let's go on and analyze the different parts of the periodic table. We have three broad classes of the periodic table, which are the representative elements, the transition elements, and the rare earth elements. Representative, when we say the representative, we mean these two parts. And this one. These two parts make the representative elements. You remember what we call the group, and it will be explained very soon. And here we have the first column, the second column. We skip this part in yellow. We go to the third, the fourth, the fifth, sixth, seven, and eight. These groups or these columns, they contain elements in the representative part. Okay? We also have the transition. The transition are these ones in yellow. These ones in yellow, these are the transition elements. And then we have the rare earth elements. They are these ones. rare earth elements. They are these ones down. Okay, you can see them. They are called the lanthanides and the actinides. We will see why they are so called. Here we also have another arrangement of the elements in the periodic table, or another way of classifying elements in the periodic table. Remember, previously we have seen three classes: the representative elements, the transition elements, and the rare earth elements. And here now we have the metals, the metalloids, and the non-metals. Okay? Let's start with the metals. The metals are these ones in the blue color, like nitrogen, for example, like this sulfur. These ones are the non-metals. Okay? And we also have metals, the ones in the yellow color. These are called metals. So in the periodic table, we have metals, we have non-metals, and we also have elements. You see them here in the green color. We have some elements here which are called metalloids. Okay? It's like on the staircase here, we have those metalloids. And the metalloids, they are so called because they present properties of both metals and non-metals, depending on the conditions. Okay? Mainly, chemically, they react as non-metals, but some of their properties, you may find them to be like those of metals, and sometimes like those of the non-metals, the physical properties. There is something you have to realize here. The biggest number of elements in the periodic table, it is the metals. See the yellow, the metals. So we have so many metals in the periodic table compared to the metalloids and the non-metals. And this, the noble gases we have here, they are also non-metals. So we can also consider them as non-metals. They are non-metals. So we go to another classification. The periodic table is also organized in groups or families. And a group is any vertical column. This vertical column, for example, this one in the yellow color, it is a group or a family. This one here, that of the noble gases, it is also a family or a group. So the vertical columns are called groups or families. And the elements in those families or those groups, they have similar chemical properties. So what do we consider to classify a given element in a given group? We just look at the outermost electronic configuration. So the valence electrons will determine the group number of a given element. If an element, let's say sodium, has a single electron on the outermost shell, then it goes in group number 1. This carbon has 4 electrons on the outermost shell, so it goes in group 4 or group 14. If you continue numbering without excluding these, then you get group 14. But if they are excluded as the transition elements, then you get 4. We can also classify elements in periods. And the periods, you can see we have an example of a period here. It is highlighted. It is any horizontal row. A horizontal row contains elements which have the same number of electronic shells, same number of energy levels. So if elements have same number of electronic shells or same number of energy levels, those ones, they will be in the same period. So for example, elements in the first period, they have 1 energy level. Elements in the 4th period, they have 4 energy levels. Okay? We can also organize elements in blocks. When organized in blocks, we have what we call the S block, and what we call the P block. A block is determined depending on the orbital which is being filled. Let's give the example of hydrogen. For hydrogen, we have this electronic configuration. For sodium, we have 1s2, 2s2, 2p6, and 3s1. So the orbital which is being filled here, lastly, it is S. So sodium will be in S block as well as hydrogen. For magnesium, you go to 3s and there will be 2. Because you are also filling S, magnesium will also be in S block. So S block contains group 1 and group 2 of the periodic table. P block contains group 3 up to group 8, with this exception of helium, which has a complete outermost shell. So from group 3 or group 13 up to group 8 or group 18, here we have P block, to mean that the orbital which is being filled, it is P. You can try to write the electronic configuration of elements in these groups. You will see that you are adding an electron in a P orbital. We also have D block and F block, and these ones, as the other ones we have S and P, their elements are classified in those blocks because the last orbitals which are being filled, they are D or F. So if the orbital which is being filled is D, then the element will be in D block, or if it is in F, the element will be in F block. If you have not understood well what we have discussed, you can go back and watch again the video. And if you are ready, let's go to the simulation and see how we can use the periodic table simulation to visualize what we have been discussing. Here we have our periodic table. When you start, it looks like this. When you start, it comes like that. We have different cards, each card with a given element, and then they go in a clear arrangement, a table, the periodic table. You may need to zoom in or zoom out. You have to use your mouse wheel. When you use your mouse wheel, you can zoom in or zoom out. Okay? If you want to see all the information given on a given card, for example, here you can see we have rhodium, we have the chemical symbol, we have the name, we have the mass number, and we have the atomic number. So if you zoom out, you will not clearly see everything written on the card. But by zooming in, you can see every information provided on the periodic table. Okay? You can use the right mouse button to move on the screen. You can use the left mouse button to rotate your periodic table. If you want, you can rotate it, okay, to view the periodic table from different angles. You can rotate it if you use your left mouse button, you hold it down and you slide, you will rotate your periodic table. Okay? And here we have our periodic table in the form of a table. Remember what we said. We said that we have groups. This is group number 1. This is group number 2. Here we have group number 13, 14, 15, 16, up to 18. We have periods, the horizontal rows, okay? These are periods. This is the second period, the third period. And we have blocks. Here we have group 1 and 2 in the S block. We have group 13 up to 18. In the P block, we have these elements here in the D block and the elements down there in the F block. Remember, we have some metals, potassium, calcium, manganese, copper. These are metals. And we have the non-metals like fluorine, oxygen, nitrogen, carbon. But we also have metalloids like silicon, germanium, arsenic. Those are the non-metals, okay? The common representation of our elements in a table is this table, the periodic table. But you can also have a representation which is in a spherical form. The arrangement comes like that. We have it. We use the left mouse button. If you use the left mouse button, you can rotate. You can rotate, okay? And if you use the right, you can slide it on the screen. And then we get our elements there. You can still zoom in and zoom out. The other things are very similar. You can also have the helix representation, which looks like that. The helix representation, you can see we have hydrogen, helium, lithium, beryllium, boron. So we have elements arranged in the order of increasing atomic number, okay? And you go down up to the last there. And we also have the arrangement in a grid form. The arrangement looks like this. You can rotate to see how it looks from different angles. Okay? See how it looks from different angles. You can zoom in and zoom out. So we have the different parts. And as I said, you can rotate. Okay? You can rotate. Where is hydrogen? Hydrogen is here. We have one hydrogen, helium, lithium, beryllium, boron. Down here, you will go to carbon, up to neon, and so on as the atomic number increases. So this is how we can use this lab simulation to visualize what we learn when we are describing the periodic table of chemical elements. I hope you have enjoyed the use of the simulation. Now let's go back to the slides and I give you the code to use if you are ready for a quiz. So if you are ready for a quiz, let's have the code. Here we have the code. It's VID 0010012. And if you have never taken a quiz, let's go through the steps. You go to opanda.xyz, you click on login, the login is here, and then you enter, and after entering, you will get this window, and then you click on take a quiz. Take a quiz is here, and after clicking on take a quiz, this is what comes, and you type the code here. That code, the code is typed here, and then you click on take the test created by your teacher. I hope you will do it. Thank you very much for watching the video. See you next time for another video.